Welcome to the Scientist's Villa, a place for the curious legends. Let's start today's video about 5 weird things that happen in outer space. It doesn't take a scientific genius to realize space is strange. Yet, exactly the way that abnormal may astound you. Space is overwhelmed by undetectable electromagnetic powers that we normally don't feel. It's likewise loaded with unusual sorts of issues that we never experience on Earth. The following are 5 absurd things that happen solely in space. First, the state of plasma. On Earth, matter normally accepts one of 3 states: solid, fluid, or gas. Yet, in space, 99.9% of ordinary matter is in a totally unique structure, plasma. Made of free particles and electrons, this substance is in a supercharged state past gas that happens when the matter is warmed to outrageous temperatures or is employed with a solid electric flow. In spite of the fact that we seldom communicate with plasma, we see it constantly. Every one of the stars in the night sky, including the sun, is for the most part made of plasma. It even shows up sometimes on Earth as electrical discharges and in neon signs. In contrast with gas, where individual particles tumultuously zoom about, plasma can act aggregately, similar to a group. The two behaviors power and is affected by electromagnetic fields, which work under exactly the same power that keeps magnets on your cooler. These fields can handle the developments of charged particles in plasma, and make waves that speed up the particles to enormous paces. Space is overflowing with such imperceptible attractive fields that shape the waves of plasma. Around Earth, the very attractive field that makes compasses point north coordinates plasma through the space all over our world. On the Sun, attractive fields send off sun-powered flares and direct bursts of plasma, known as the sunlight-based breeze, that movement across the nearby planet group. At the point when the sun-oriented breeze arrives at Earth, it can drive enthusiastic cycles, similar to the auroras and space climate, which, if sufficient, can harm satellites and broadcast communications. Extreme temperatures. From Siberia to the Sahara, Earth experiences an extensive range of temperatures. Records exist as high as 134 degrees Fahrenheit and all the way down to -129 degrees Fahrenheit. But what we consider extreme on Earth is average in space. On planets without an insulating atmosphere, temperatures wildly fluctuate between day and night. Mercury regularly sees days around 840 degrees Fahrenheit, and frigid nights as low as -275 degrees Fahrenheit. And in space itself, some spacecraft experience temperature differences of 60 degrees Fahrenheit. Just between their sunlit and shady sides. That would be like having a glass of water in the shade freeze on a hot summer day. NASA's Parker Solar Probe, at closest approach to the Sun, will experience differences over 2,000 degrees. The satellites and instruments NASA sends into space are carefully designed to withstand these extremes. NASA's Solar Dynamics Observatory spends the vast majority of its time in direct sunlight, but a few times a year, its orbit passes into Earth's shadow. During this cosmic conjunction, otherwise known as an eclipse, the temperature of the sun-facing solar panels drops by 317 degrees Fahrenheit on board heaters, however, turn on to keep the electronics and instruments safe by permitting only a half a degree dip. Similarly, engineers build astronaut suits to withstand temperatures from -250 degrees Fahrenheit to 250 degrees Fahrenheit. The suits are white to reflect the light while in the sunshine, and heaters throughout the inside keep astronauts warm in the dark. The design also provides consistent pressure and oxygen, and resists damage from micrometeorites and the sun's ultraviolet radiation. Third weird thing, cosmic alchemy. At this moment, the sun is getting hydrogen into helium at its center. The method involved combining particles under colossal tension and temperature, manufacturing new components in the combination. At the point when the universe was conceived, it contained generally hydrogen and helium, in addition to a sprinkle of a few other light components. A combination of stars and cosmic explosions have since outfitted the universe with in excess of 80 different components, some of which make life conceivable. The sun and different stars are magnificent combination machines. Consistently, the sun wires around 600 million metric huge loads of hydrogen, That's the mass of the Great Pyramid of Giza multiple times. Alongside the formation of new components, the combination discharges gigantic measures of energy and particles of light called photons. Deeply. From that point forward, the light just requires 8 minutes to venture to every part of the 93 million miles, 150 million kilometer, to Earth. Researchers previously showed splitting, the inverse atomic response that divides weighty components into more modest ones, in labs during the 1930s. Today it's utilized in thermal energy stations. The energy delivered in parting can make a calamitous bang. However, for a given measure of mass, it's as yet a few times not exactly the energy made from a combination. Nonetheless, researchers have not yet sorted out some way to control the plasma in a manner to deliver power from combination responses. Fourth, magnetic explosions. Every day, the space around Earth booms with giant explosions. When the solar wind, the stream of charged particles from the Sun, pushes against the magnetic environment that surrounds and protects Earth, the magnetosphere, it tangles the Sun and Earth's magnetic fields. Eventually, the magnetic field lines snap and realign, shooting away nearby charged particles. This explosive event is magnetic reconnection. While we can't see magnetic reconnection with our bare eyes, we can see its effects. Occasionally some of the perturbed particles pour into Earth's upper atmosphere, where they spark the auroras. Magnetic reconnection happens all across the universe wherever there are twisting magnetic fields. NASA missions like the Magnetospheric Multi-Scale Mission measure reconnection events around Earth, which helps scientists understand reconnection where it's harder to study, like in flares on the Sun, in areas surrounding black holes and around other stars. Fifth, supersonic shocks. On Earth, a simple method for moving energy is to give something a push. This regularly occurs through impacts, similar to when the breeze makes trees influence. However, in space, particles can move energy without contact. This abnormal exchange happens in imperceptible designs known as shocks. In shocks, energy is moved through plasma waves and electric and attractive fields. Envision the particles as a group of birds flying together. Assuming that a tailwind gets and pushes the birds along, they fly quicker despite the fact that it doesn't appear as though anything is impelling them forward. Particles act similarly when they out of nowhere experience an attractive field. The attractive field can basically give them a lift forward. Shock waves structure when things move at supersonic rates, quicker than the speed of sound, that is. Assuming a supersonic stream experiences a fixed item, it frames a bow shock, similar to the bow wave that is made at the bow of a boat moored in a quick stream. The sun-powered breeze makes a bow shock when it blasts through Earth's attractive field. Shocks appear somewhere else in space, as around dynamic cosmic explosions launching billows of plasma. In uncommon cases, Earth can have impermanent shocks, for example, when projectiles and planes travel quicker than the speed of sound. All 5 of these strange phenomena are common in space. Although some can be reproduced in special laboratory situations, they mostly can't be found under normal circumstances here on Earth. NASA studies these weird things in space so scientists can analyze their properties, providing insight into the complex physics that underlies the workings of our universe. Here are 5 weird things that happen in outer space: the state of plasma, extreme temperatures, cosmic alchemy, magnetic explosions, and supersonic shocks.